Right, so here's something I've been thinking about all morning. Yann LeCun just walked away from Meta with over $1 billion to basically say the entire AI industry is building things the wrong way. And I don't know whether to be excited or terrified by that. Let's explore this.
This is genuinely one of the most interesting moves I've seen in years. We're talking about 890 million euros, which is roughly $1.03 billion. That might be the largest seed round in European history. But here's what makes it fascinating. LeCun isn't building a bigger language model. He's building something completely different.
So what is he building? Because I know he's been pretty vocal about thinking language models aren't the path to proper AI, right?
He calls them world models, systems that learn by observing and interacting with the physical world, not by reading text. His argument is that language is actually a pretty inefficient way to learn about reality. A child learns what a cup is by picking it up, dropping it, watching it fall, not by reading descriptions of cups.
Okay, but here's my question. Is he saying language models are useless, or is he saying they're incomplete? Because those are very different bets.
Incomplete. He's arguing that text-only training gives you systems that are good at language, but fundamentally lack common sense about how the physical world works. So AMI Labs is focusing on vision, robotics, representation learning. The team he's assembled is almost entirely vision researchers.
That's actually really interesting because we've covered stories recently about robots that can plan visual tasks. There's this MIT research where they built a hybrid system. The robot uses a vision model to understand what it's seeing, then translates that into formal planning language that traditional software can solve. And they went from 30% success rate to 70%.
Right, and that's the pattern I keep noticing. The breakthrough isn't the model itself, it's the structure around the model. MIT didn't make the vision model better. They built a better system by combining neural networks with classical planning algorithms. Each does what it's good at.
So let me connect this to something practical. There's this essay from LangChain about what they call harness engineering, and it's basically the same idea. The harness is everything that isn't the language model. The file system, the memory, the verification loops, all the infrastructure.
Oh, I read that piece. Here's what I noticed was this line. The teams seeing the biggest returns on agent systems aren't using the newest models. They're the ones who've invested in harness design. That feels really important.
It is important because I see this with clients all the time. They think if they just use a more powerful model, their problems will solve themselves. But actually the model is only as good as the system you build around it. If you don't have proper state management, error handling, feedback loops, even the best model will fail.
And this connects directly to LeCun's bet. He's saying the industry is obsessed with scaling models when we should be building better architectures. World models are his version of that architecture. Systems that ground intelligence in the physical world, not just text.
Right, but here's what I find genuinely exciting about this. He's not saying language models are wrong, he's saying they're one piece of a larger puzzle. And honestly, I think he might be onto something because when you look at how humans learn, we don't just read. We touch things, we move through space, we make mistakes and feel the consequences.
Ah man, speaking of feeling consequences, there's a story today about surgeons getting their sense of touch back through robotics. And honestly, this one moved me a bit.
Oh, tell me about this. I saw the headline but haven't dug into it yet.
So minimally invasive surgery saved lives, right? Smaller incisions, less trauma, faster recovery. But it costs surgeons something vital. The ability to feel inside the body, to detect whether a tumor feels different from healthy tissue. That tactile feedback is irreplaceable.
The palpable project. They're building soft robotic fingertips with fiber optic sensing embedded inside. When the tip presses against tissue, the light traveling through the fibers changes slightly. Those tiny shifts translate into information about tissue stiffness. The surgeon gets a visual map showing softer and firmer areas.
That's beautiful. You're giving surgeons back their sense of touch, but digitized, so they can feel what they're operating on without actually being able to physically touch it.
And the prototype is being tested by surgeons right now, which means we're very close to seeing whether this actually works in a real operating theatre. If it does, that's profound. Surgery doesn't just become more precise, it becomes more human again.
This is where robotics gets interesting for me. Not the flashy demos, the unglamorous work of solving real problems that people actually have. Surgeons need to feel tissue, so you build a system that gives them that feeling back.
And honestly, this connects to something else that came up today. Public sentiment on AI has turned genuinely hostile, not skeptical, hostile. And I think part of the reason is that people see the flashy demos, but they're not seeing the real help.
I've been thinking about this a lot. Previous waves of automation displaced people at the bottom of the economic pyramid. Assembly line workers, clerical staff. But AI is different. It's targeting creative work. Writing, coding, design, the things people built their identities around. That's not just economic anxiety. That's existential.
There's also a timing issue. AI arrived right after social media scandals tanked trust in tech companies, right when people were feeling economically insecure. So the ground was already poisoned before AI even showed up.
Right, but here's what I think needs to happen. Not more capability demonstrations, not VCs talking about parameters and scaling. What needs to happen is surgeons showing how this gives them their sense of touch back. Nurses showing how it eliminates hours of paperwork. Factory workers showing how it lets them do safer, more creative work.
That's the conversation that builds trust. Not look how powerful this is, but look how it actually helps. And I think that's starting to happen. Humanoid robots are moving from YouTube demos to real factory work. There's a keynote at the Robotics Summit in May specifically about cutting through the hype and asking what these robots can actually do right now.
That shift from demo to deployment is where real progress happens, and it's the honest conversation that needs to happen more often. Here's what works, here's what doesn't. Here's what we need to improve before we scale this.
Okay, so let me bring this back to something practical for people actually building with AI. There's this pattern emerging called the brief method, and it sounds simple, but the difference it makes is substantial.
Oh, I've been using this with Claude. It's brilliant. Instead of asking the system make this function better, you structure your prompt into 4 parts. Context. What is this code and where does it live? Task. Exactly what needs done. Constraints. What should not change? And success criteria. How will you know it worked?
This is harness engineering again. You're not making the model smarter. You're giving it better signal about what matters. Teams that have made brief writing their standard way of delegating to AI are seeing the biggest returns. It's methodical, unglamorous, but it works.
And I think that's the thread running through everything today. Raw capability matters less than how you structure systems around it. Whether you're building a harness for an agent, designing a 2-stage planning system for vision tasks, or architecting error correction into a quantum processor, the structure is where the real work happens.
Speaking of quantum, there was progress on formal verification of quantum circuits today. Researchers figured out how to verify circuits with over 1,000 qubits. That shouldn't be possible because the state space explodes exponentially, but they managed it with less than 3.5 GB of memory.
The technique is called quantum phase estimation verification, and it matters because you can't just test quantum circuits like you test normal code. The verification has to be formal and mathematical. This is infrastructure work. Not flashy, but it makes larger, more practical quantum systems possible.
There were also 3 advances in quantum error correction. Scalable post-selection that reduces overhead by a factor of 4. New understanding of how to physically build quantum codes by stacking components, and better ways to couple diamond quantum memories to control systems with minimal signal loss.
These aren't the announcements that make headlines, but they're the advances that actually move the field forward. Better error correction, better verification, better physical systems. That's what makes quantum computing real.
And it's the same pattern again. The breakthrough isn't the raw capability, it's the engineering that makes the capability usable. That's what Lacan is betting on with world models. That's what MIT showed with hybrid planning systems. That's what the brief method does for AI coding. Structure matters.
So looking across everything today, I think there are 3 things worth taking away. 1. We're at a genuine fork in how we think about AI. Language models versus world models. Both might be true, both might be necessary, but the industry needs to stop pretending there's one obvious path.
2. When the work moves from demos to real surgery, real factories, real lives, that's when we learn whether the technology actually delivers. And the honest conversations happening there matter more than the capability announcements.
And 3. Trust rebuilds when people see technology solving their actual problems. Not the hype, the real work, systems design. It's not new, but it's easy to forget when everything feels like it should just work out of the box.
Right. So what do you think? Are language models enough, or do we need world models too? Are you seeing AI actually help with real problems, or is it mostly noise? We'd love to hear your thoughts. Drop a comment below and let us know. That's it for today. If you're enjoying this, our newsletter lands in your inbox every evening, completely free. It's the written version of what we're covering here, with links to everything and more depth to dig into. Head to luma.marbl.codes to sign up. All the links to the stories we mentioned are in the description below. And if you found this useful, hit subscribe so you don't miss the next one. We're building something here and we'd love to have you along for it. Oh, and one more thing. If you're thinking about how AI fits into your career or your team, we're building a waitlist for Atlas AI talent. It's early days, but if you're curious, there's a link in the description. Thanks for listening. See you next time.